All right, so we're going to finish off the last class before spring break by reviewing, well, what do the sine inverse, cosine inverse, and tangent inverse buttons do on your graphing calculator? Well, those are called the inverse trig functions, not to be confused with the reciprocal trig identities, such as cosecant, secant, and cotangent, but we will go back to those at a later date. But I just want to make sure that you guys understand that these are what are called inverse trig functions. So you have sine, cosine, and tangent. Well, sine inverse, cosine inverse, and tangent inverse are used for solving unknown angles of a right triangle. So before, you were given an angle measurement, one of the sides, and you wanted to use that information to solve for another side length. Well, in this, let's just say I give you three side lengths, and I'm going to do this problem in three separate ways. So let's say I want to figure out, well, how do I solve for this unknown angle right here? We call this angle theta. So let's just say I do, normally there's going to be two sides, but let's just say I give you all three. Well, there's three ways to do this because you have three sides of a right triangle. So let's say I pick 5 and 13. So if I look at angle theta, and I've got side length 5 and side length 13. Compared to angle theta, what is 5? Opposite, adjacent, or hypotenuse? It's the opposite. Okay? Compared to compared to angle theta, what is 13? Opposite, adjacent, or hypotenuse? It's the hypotenuse. So the one that's unknown is the angle theta. So in other words, if I look at this diagram and I say the sine of angle theta, because I have an opposite and a hypotenuse, the sine of angle theta is 5 over 13. However, how do I undo the layer of sine? Well, I know what you're thinking. It's not cosecant, but rather the inverse sine. So I'm going to rewrite it. Sine of theta is equal to 5 over 13. But what I'm going to apply on both sides of the equation are, I'm going to apply sine inverse. And if you take algebra 2 or pre-calculus, you'll know that an inverse function cancels out and gets you back to the identity, in this case angle theta. So now angle theta, I'm going to go to my calculator. So let's just say I use the Google one, since I don't know if you guys have graphing calculators at home. I'm just going to clear everything. Whoop. One thing, make sure you're in degrees. So if I go to Google and I type in calculator, you'll notice that there is no sine inverse, cosine inverse, tangent inverse. But if you click this button that says inverse, it makes everything go to the inverse. Okay, you see? Natural log, logarithm, square root. All of a sudden they turn into their inverses. Pretty cool little tip for algebra 2. Anyway, so I want to take the sine inverse, or arc sine as it's called in some books, but it's the sine inverse. The sine inverse of 5/13. So I take arc sine, or sine inverse, of 5 divided by 13. And that tells me that if you have a sine ratio that is 5/13, they meet at the angle and form a 22.6198 degree angle. Well, I could just round up after that fourth decimal place. I could make this 22.620 degrees. 22.620 degrees approximately. Okay, so again, I just give you a diagram, and I'm going to see if you guys can do this in another way. So I used 5 and 13. Let's pick up another pair. Let's say I pick 12 and 13. So if I look at angle theta and I pick 12 and 13, compared to angle theta, what is side length 12? Opposite, adjacent, or hypotenuse? It's the adjacent side. And compared to the angle theta, what is 13? The opposite, adjacent, or hypotenuse? 13 is the hypotenuse. what trig ratio will let me use an adjacent side, hypotenuse? What trig ratio will let me use an adjacent over a hypotenuse? We've got the cosine. So the cosine of angle theta is adjacent over hypotenuse, or 12 over 13. Well, considering that sine inverse cancels out with sine, well, what's going to cancel out cosine? So I'm going to rewrite it. I'm going to apply cosine inverse to both sides of the equation. Oops, let me make that a little bit clearer. So I'm applying cosine inverse to both sides because the inverse function, if you're going to take algebra 2, cancels out with the original function to get to the identity. Kind of like squaring and square rooting. So I'm going to get, I'm hopefully going to get the same result, 22.620. So I did, let me clear. So I'm going to go to my inverse and say the cosine inverse of 12/13 is still 22.6198, or exactly what we got, 22.620 degrees. And remember, we are in degrees. Okay? So just to show you that we did it in two ways, let's take a look at it in a third way. So we did the sine ratio, we did the cosine ratio. Now let's see what we can do with the tangent ratio. So I'm going to pick 5 and 12. So specifically, 5 is the opposite side of angle theta, and 12 is the adjacent side of angle theta. So why don't we use the tangent ratio? So specifically, hang on, let me get the focus back in. Okay, so the tangent of angle theta is 5 over 12. And we're going to rewrite it. And how do we cancel out the tangent? If sine inverse cancels out with sine, and cosine inverse cancels out with cosine, what cancels out tangent? To solve for the unknown angle, let's apply the tangent inverse to both sides. So I'm going to cancel out tangent inverse and tangent, and that leaves me with angle theta. Hopefully, we also get 22.620. So I'm going to clear that. I'm going to go make sure I'm in degrees. Inverse, tangent, and the tangent ratio was 5/12. And that is still about 22.620 degrees. Okay, just to show you that depending on the information that we're given, you are capable of solving for that unknown angle. I'm going to give you guys 3 problems, and then I'm going to say happy spring break. Okay, so let's see if you can do these 3 problems independently. Okay. All right, so looking at angle theta, what information do we have? Well, if I look at angle theta, right, the side lengths that I know, right, so angle theta means I don't know the angle. The side lengths that I know are 5 and 9. Well, 5 is the opposite side, and 9 is the hypotenuse of the triangle. So therefore, what this diagram is telling me is you use the sine of angle theta is equal to 5 over 9, and then you apply the sine inverse to both sides. And your sine inverse will cancel out the sine function. So the sine inverse of sine of theta is equal to the sine inverse of 5/9. So sine inverse cancels out with sine, leaving me with angle theta. And I'm going to apply the sine inverse of 5/9 into the graphing calculator. So inverse sine inverse of 5/9. So that'd be 33.748. The fourth decimal place is a 9, so I'm going to round that up to 33.749. 33.749. And remember, we are in degrees, so we have to put a degree symbol. Otherwise, it is assumed to be radians. Okay? So if an angle measurement meets with an opposite side of 5 and the hypotenuse of 9, it has to have a 33.749 degree angle. Okay? What information do I have here for problem number 3? Well, I've got two side lengths that I know, and I want to solve for this unknown side length. So let's say I look at angle theta, and I say 17 is a side length that I care about, and 23 is a side length that I care about. Well, 17 is my adjacent side, and 23 is my hypotenuse. So what trig ratio am I going to use? Adjacent over hypotenuse tells me that this is the cosine of angle theta. So the cosine of angle theta is 17 over 23. Remember, that's because it's adjacent over hypotenuse. Pay attention to which one is which. So now I'm going to cancel out that cosine by applying the cosine inverse on both sides of the equation. So I've got the cosine inverse. That's going to get applied. The cosine inverse cancels out with the cosine, leaving me with angle theta is approximately, so let's apply the cosine inverse, so I'm going to go to make sure I'm in degrees, cosine inverse of 17/23. So that would be 42.3426, blah, 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 blah. So let me just get this down. So I'm going to look at the third decimal place, and I'm going to look at the fourth decimal place. And does that round up or round down on that third decimal place? Well, it's 5 or higher, so I'm going to round this to 343. So 42.343 degrees, so about 42 degrees. But there you go. Okay, and finally, for the last problem, before I send you guys off on your spring break, look at angle theta. What two side lengths do we know? We know 15 and we know 7. 15 is the opposite side, and 7 is the adjacent side. So which trig ratio involves an opposite and an adjacent side? The tangent of angle theta is equal to 15 over 7. So what do I do to cancel out the tangent ratio? I'm going to apply the tangent inverse to both sides because an inverse function cancels out with the original function to get to the identity. A little helpful hint for algebra 2. So angle theta is equal to the tangent inverse of 15 over 7. So clear, clear, clear. Let's go to degrees, make sure. So the tangent inverse of 15/7 is 64.9831. And remember that fourth decimal place is 1, so that rounds down. So 64.983 degrees. Okay, so I'm going to assume that you're looking at your notebook right now. So how do you know if you got the correct answer? Well, the thing that I love about trig is that you can compare the diagram and you can compare the decimals of the trig ratio. And they should be almost identical. So remember that the sine in the diagram was 5 over 9. And I believe 5 over 9 is 0.5 repeating. Yeah, 0.5555555. So 5 over 9 is the sine ratio of this diagram. And so we've got 33.749 degrees, 33. So that would be the sine of 33.749. And it should be approximately 0.555555. There you go, pretty close. The more decimal places you use, the more accurate your solution is going to be, but close enough. Okay, same thing over here. So if I compared the cosine of 42.343, let's do the cosine of 42.343, whatever that is, I don't know. It's 0.739, blah, 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 blah. And if I compare that to the diagram of 17 divided by 23, do I get the same decimal place? There we go. And finally, the last one, I'm going to compare the tangent of 64.983 So the tangent of 64.983 degrees, not radians. I don't know what that is, but it's about 2.142. Okay, so let's hope that 15 over 7 follows that same ratio. Let's go 2.142. There we go. Oh, man. So that's how you can check your work. Trigonometry has many ways to check your work. Hope you guys have a healthy, safe spring break. I miss you guys a lot. It's very painful. Stay safe, and I'll see you guys in about 10 days. All right, have a great day.